Moving on to the next session, we now need to calculate the log return. Here, first, it's just some assignment that I just want to keep the original downloaded data in this data frame, but I want to change the data frame that I'm going to do some manipulation. Here I first rename this adjusted clause to this adjusted underline clause. This sort of name is more friendly in case I want to, for example, save this file as in a file in CSV file or some other format. When there is a space, sometimes it's going to create some problem if I want to, for example, import this data into some other program. I define here a variable called logret that I'm going to calculate this adjusted clause. I'm going to calculate a return based on this adjusted clause. So again, here this is some sort of software specific. This shift 1 gives some lag to this adjusted clause. Whatever software you are going to use, you need to divide, for example, today close to yesterday close. This shift just does this lagging in a way that it can be used to perform this calculation. And here again, another note here is that you see np.log. np, if we go back up here, this numpy is some standard package for Python. Instead of just repeatedly using numpy, this is common practice. I just gave some shorter name for this library. So from now on, whenever I write np, this program understands it as numpy. I do it because I need this log function which is in numpy to perform this operation. And in this line, in any software, you need to have this sort of facility that in some way you need to get rid of these non-values, not a number values, or any sort of problematic data issue. In Python, we can use this method drop NA to do this task. Maybe in R or in MATLAB, you need to find the indices of non values and, for example, delete those indices from your data. Anyhow, after performing these steps, we see that we get a data frame that contains this log return column, and it starts from this date in our data frame. Well, moving on to the next step, we need to calculate a summary statistics. As mentioned in the question statement, it can be done from the specific function that usually is provided in the software. For Python, we can use this describe method to obtain mean, for example, mean, standard deviation, minimum data, and this 50% is 50% quantile or the median, and this sort of statistics. Well, depending on what on the analysis or your purpose, you can analyze this data. For example, here median is almost 5 times the mean. Well, we know in symmetric distribution, the mean and median coincide with each other. So here there is some evidence that this distribution At least it's not symmetric, so it may not follow a normal distribution. Well, if you notice, I changed back this background to white color because these plots can be shown better in the white color. Anyhow, in this step, we are required to plot the histogram of the log returns. To do this, there are so many ways to plot a histogram in Python. Even there are some other packages that they provide much more flexibility when you plot histogram, or they are simply easier to use. Anyhow, one way to do it is just to use the built-in method that is provided in the Python pandas and plot this histogram. Here this beans specifies this width that data are categorized. For example, if I use a larger bin, this data is going to be categorized in narrower width. Well, this is it for this part. Now let's move on to the next step. In this step, we are required to perform a normality test and formally test to see whether this data follows a normal distribution or not. As you notice, I'm going to import this package to perform this test, and I'm going to use this function in this package. There are, of course, some other normality tests, but this is one common choice that can be used here. After performing this test, we get a p-value of 0, which simply means we reject that this data follows a normal distribution. Well, moving on to the next part. In this step, we are required to plot the autocorrelation of this data. Well, I'm going to use this package, and needless to emphasize that we need to always be ready to go to Google and do some search to see or to find the best way that we can perform some task. Again, there are several other ways to obtain this autocorrelation function. When you try them, naturally you are going to pick the one that you think it's better for you. Here I'm going to use this stat models package and this plot ACF function from this package. After obtaining this autocorrelation, we see that this band sorta is specified by this alpha, which is a significance level we choose here. This shows that any data point out of this band is going to be significant at 5% level. Anyhow, apart from being statistically significant, we always need to note that is this statistically significant value is also economically or of practical importance. Here, another point is that we can see this is one stylized. There are a few stylized facts in finance. One of them is this, that there is no autocorrelation in the data. Here we can see to some extent that this fact holds here. Moving on to the next part. In this part, we are required to calculate the square of log returns. Well, we simply use this function, which is from this standard package NumPy, and perform this task. One important or something to note here is that as you can see here, I simply use this NumPy square on a data frame object. Not all software provides such convenience. For example, if you want to perform some calculation, you need first to obtain the data from the data frame, convert it to matrix or vector or some other object that you can compute the required quantity that you want. But this is one of the convenience that is provided by Python language, that we can simply use any NumPy function, of course if it is applicable on a data frame. Anyhow, after performing this task, which we are going to save in another variable called this logret underline square, and printing this data frame, we obtain that this extra column in the data frame. Moving on to the next session, we are required to plot the autocorrelation of this square of the log return. Again, using the previous method that I explained, we are going to obtain this autocorrelation function between the square of the log return. Again, we come to another stylus fact of these financial assets, that there is almost high correlation or autocorrelation in the square of the return of the financial assets. Well, this is it for this empirical exercise. Needless to say that this exercise is by no means comprehensive or complicated, but I guess it's enough to just give you a taste of the kind of work or the kind of task you need to do if you choose to go on the path of for example, financial engineering, quantitative finance, or any subject that requires intensive computation. Well, this is the end of empirical exercise for the statistical method for finance.